Okay, so today we're going to look at using transition matrices still, but we're going to look at this thing where we get to a steady state or a long term using the transition. We've seen it previously in one of our exam questions, but what you notice, if you keep using the transition and you end up getting to a high power on the T, so you're going lots and lots of states ahead, you'll notice that you no longer are getting a different matrix. So take this example here. They're just showing you with the transition matrix. So they started it off with this matrix and they did it to the power of 2, and we saw it go like that. But you can see once we keep going, once we got to this high power, we got this matrix down here. And you can see if we go to power of 51, we're getting the same. So when you start getting the same, what we say is it's reached its steady state. So it's no longer changing. So the steady state, sometimes we say in the long term, you might see that wording used, and that still means the steady state. So sometimes they ask us what is, the actual steady state. So using our power trick, which is down here, summarized down here, remember we can find any matrix state by going the transition to the power of it times the SO. Well, when you're trying to find the steady state, we just need to put in a high power, because generally if you got a very high power, you would have made it to the steady state. So often on our calculators, I just often like to just use the power of 50 times the beginning SO, and that will get you to the steady state. So whatever that ends up being, that'll tell you what the steady state is. Okay, so this was our example, if you remember back when we had the rain. So we had the transition matrix of whether it was dry or rainy on that day, and we times it by our original scenario. So say it was raining on one day and dry on the other day. So if we did that, and you can notice they just keep going. So here when they did state 7, they would have done the transition to the power of 7 times that beginning scenario. And we see here's the chances of rain is 62%, and the chance of dry is 37. So if you keep going, 8, 9, you actually realise between here and here, see how it's remaining the same. So the chance of rain is 62.5%, and the chance it's dry. And when it doesn't start changing, we know we've reached the steady state. So we might say, and here they've said, so in the long run, the probability of rain, that one, is 62. We might say in the long run, probability of rain or percentage of rain is 62.5%. Okay, so you would have got there if you did ST to the power of 50, but because you definitely passed the 9th and 10th day. So it depends on whether they want you to show, if they want you to prove the steady state. So say they wanted you to prove the steady state occurred at day 9 or something, you would show that state 8, you would have done the transition, time to the power of 8 times SO, you would have shown that it gave the answer it did. So I'm just going to say 62.550 whatever, and 0.3749 whatever, and then you'd show that S9 got your answer, and then you'd show that S10 got the same. So you don't have to write all the transition out. You can just do like what I just did there, and you can just show, and you say therefore these two are the same. Show you're proving that you've reached a steady state. That's only if you're asked to prove. We'll do some exam questions and I'll show you anyway. Okay, so with this one, this was the car rental place, and you had 2 locations. We have forgotten, obviously. We've got, we're going to say location A and location B. So this was A, B, A, B here. And it says estimate the steady state solution by calculating what happened on, say if this was week to week for the car rental, so week 10. So I've popped in here, here's the transition to the power of 10 times our original, and we got here. So at venue A, we've got, say, we'll round that up, we've got 31 cars, and at B we've got 59 cars. So then if we look at, if we do day 15, we see A and B, we've got 30 and 60, so that's still changing. Then when we did 17, A and B, if we round it, we've got 30 and 60, and you get to 18, A and B, and you can see 30 and 60, so you can see that it's not changing now, that it's rounding off, so we've reached the steady state. So we would say, so we're reaching the steady state, it's not changing, so we'd say the steady state scenario is 30, 60. So at A we've got 30 cars, and at location B we've got 60. So in the long run, we might say in the long term, this business is going to want to be keeping 30 cars at A and 60 cars at B. So they know that because that's what the pattern's showing. Okay, so here's another one. It says the initial matrix is SO is here, and the transition, and they just want you to do find the steady state. So they're not saying prove it, they're just saying find it. So we're just picking that high power of 50, and we find it in here. So there it is. And so just to, put your mind at ease, just highlight up on your calculator, do 51, and you can see that they're the same. So when they ask for the steady state, you just pop in, depending what they say to round to. I'm going to do a whole number. I'm going to say 76 and 59 is the steady state. Okay. Okay, so we've got 3 brands of chocolate that dominate the market, brand A, B, and C. People change from one brand to chocolate to another all the time, and the transition matrix to represent this is shown. If they were initially, so here they're giving it away initially, that's generally what they're giving you the SO scenario. So because you're going to have 3 brands, you're going to have your SO will be a 3 by 1. So it said initially 300 people you had brand A, so there's 300. 425 were at B, so 425, and C, it was 250 at B and 425 at C. Okay, so it asking in the question, in the long term, how many people will be using each brand. So into your calculator, put the transition to a high power and times it by SO, which is what I've done there, and I get that. So remember, this would be A, B, and C. And just for peace of mind, I chucked it up, I just highlighted it, chucked it in 51, make sure it's definitely not changing. So yeah, good, I've reached it. So if we wrote out the steady state, just summarise to the whole number, so A, B, and C, we'd have 4, 3, 9, we'd have 2, I'm going to round up, so 2, 2, 8, and then we've got 3, 0, 9. Okay, so if you look there, so we've got the thing, and it says how many people in the long term are using each brand. So you need to make a statement. So brand A, 439 people, B equals 228, and C equals 309. Now I just want to bring to your attention here, in this scenarios, we shouldn't be losing any people. We're like the same people getting are following through. So if we look at here, that we have a total people of 975 people. Okay, so really when I add this up down here, I should have 975. And what I don't actually have that. If you add up these two numbers, we actually get 976. And that was mainly because, see this one here, the 227.5, I rounded up. And so by rounding up, I'm sort of, because I round the other two up, we're sort of gaining it. So we probably need to change this one to, it would probably have to say 227. Okay, so I don't think they'll do this nicely in the exam, but just to show you, it shouldn't remain, you haven't lost or gained any people. So it should always add up to, your total should add up to what you had in the beginning. Okay, when buying fruit in the winter, people alternate between oranges and apples. So 75% of the people who buy apples would buy oranges. So here they're setting up a transition. So we're going to have to set up our transition. And we might say, so it's the first one, it says 75 people who buy apples buy oranges. So I'm going to go apples, oranges, oranges. So this is, this time, and this is next time. So if we go through it, and it says the first bit where it says 75% buy oranges, who buy apples buy oranges next time. So I'm going to see apples this time, oranges next time. I'm going to change that to a decimal, because remember our transitions need to add up. And then the next one, piece of information, it says 55% who buy oranges buy apples the next time. So oranges buy apples, 0.55. Now these have to add up to 1. So that means I can fill in the blanks. That would have to be 0.25 and this would have to be 0.45. So now I've got the transition matrix. Now here, the next thing they say, on the first day of winter, 85 people had apples and 120. So what they've given you there is your SO. Now remember, your SO must match with A on top and O on the bottom. So 85 apples, 120 oranges. Now the question is actually asking in the long term the number of oranges to be sold. So you can see long term, that would mean I put the transition to a high power, and I'm choosing 50 times by my SO. So I've done that here. I get this answer. So this would be apples and oranges. And I've just chucked in 51 to check. And yep, I've reached it. So we're probably going to just summarize and say that's 87 and this is 118. So if we checked, we had 205 to begin with, and we've still got 205. Yeah, so that's okay. So that's what happens. Now it doesn't actually matter, and I just wanted to bring this to your attention. It doesn't actually matter what state matrix you pop in there. So you could actually use, S1, S3. If you're doing that transition to a high power, you're getting to the same spot anyway. You're always going to reach the long term. And just to show you that, so in there, say for example, we knew there was 205 people. So just to show you, I've shoved all the people, I said all the people buy apples. But if I do the steady state, so I use a high power, you can see we end up at the same spot. So we end up with 87 apples and 118 things. So it doesn't matter too much which state you use. And as long as if they're asking for a number, you've got to make sure your number of people was correct. So that's why I could put 205. If I put 205 in the oranges and left 0 in the apples, I'll still get the same answer. So the question was, in the long run, how many oranges? So I better be saying that. So oranges, so we might say 118 oranges are sold each day in the long run. In the long run. So we need to make a statement if they're asking us a question. We need to, in the long run. You need to write an answer out. Okay, so question 7. Each week, 300 students at primary school choose art, music or sport for an afternoon activity. Transition below shows how they change from week to week. Now, based on this information, it can be concluded in the long run. So they wanted me to do the long run. So if you think about it, we know, which is the same as steady state. So we know we find the steady state by going the transition to a high power times SO, or it can be any state as I showed you before. So what I'm going to do, we don't really know how they begin with, but we do know there's a total of 300 students. Okay, so as long as I'm going to chuck that transition in, which I've got here, raise it to high power, and I might decide I'm going to put 100 kids in each section, even out those 300 kids. So that would be art, music and sport. Okay, so you end up and you pop that in, and I've done that down here, and art, music, sport. So I get 105, 100, and remember we want to end it up being we want it ending up being 300 in total. So I'm actually going to keep this one at 109, and I will raise this last one to 86, and that's going to give me a total of 300. Okay, now if you if you decided to chuck them all in, I'm going to say they all did music to begin with, you can see in the long term I still got the same answer. So art, music, sport. So then we can look at this long term thing and answer the question. No student will choose sport in the long term. That's wrong. We've got 86. So that's not right. All students will choose to stay in the same activity each week. That's not right. We know they're changing. If that was to happen, you'd see a 1, meaning 100% of those who go to you'd see a 1 in the transition, meaning 100% of them who picked one thing go to the same thing. All students will have chosen to change their activity at least once. Now that's not true either, because you might be, say for example up here, this 50% of this week, 50% of next week, of those people will do art next week, but it could be a different kid that then chooses the following week. So that's not, this data does not tell us that, so we're going to say no, we can't be sure. More students will choose to do music than sport. So if we're looking at it, this is true, because we've got 109 doing music and 86 doing sport. That's a good statement. I'm happy to go with that. And if we just check that the last one was wrong, the number of students choosing to do art and music will be the same. Well, that's wrong. We can see that. So we'd say no. Okay, so this is just another example. They had hairdressers can choose which hairdresser they want to cut their hair, and here's a transition setting it up, and they did here in the blue give you the SO of what's going on. So you've got the Shirley, Jen and Naj doing it, and they said what begins with, they all had 200 each. Okay, so then it says in the long term, the number of regular customers expected at Shirley. So all you're just going to do is put that transition to a high power, times it by this SO we created, and we'll see what happens. So they've just done the storing, but we can see down here, they end up with 171, 204, and 225. So how many, if you look at this, would have been Shirley, Jen and Naj. So how many in the long term who were expected to choose Shirley? How many people expected to choose Shirley? Closest to, we're going to go 170. There's 171. Okay, a public library organised 500 of its members into 5 categories according to the number of books each member borrowed. So there they are, and they've categorised them J, K, L, M, and N. And they reckon that these people changed their type of category they're in using this transition. And you can see here in the question, it says, in the long term, which category is expected to have approximately 96 members? So you were never given an SO, but remember I said it does, but you were given a total. So you've got 500. And remember I said it doesn't matter how you divvy them up. So I did over here, I've done the transition because we want the long term. So I've done the transition to a high power, and I just chucked them all in the first one. And it doesn't matter because we've shown you, I've proved to you, it won't matter. And so when we do that, they all end up in the long term. This is the long term. What's happening here? This is the answer. So we've got J, K, L, M, N, and they just wanted to know which one had 96, and it was K. So we just do K. So what I'm saying is it wouldn't have mattered. So say someone decided to do the transition times to a high power, and they say they, over the 5 categories, they put 100 in each. Yeah? So it still adds up to 500. You will still get the same answer. You'd get exactly the same. You'd get this answer up here. And so it doesn't matter. Okay, question 3. The High Roads Company has a contract to maintain and improve 2,700 kilometres of highway. Each year, the sections of the highway must be graded, resurfaced or sealed. The remaining highway will have no maintenance that year. Let SN be the state matrix that shows the highway maintenance scheduled for the nth year after 2018. The maintenance schedule for 2018 is shown below. Okay, so just so, sometimes it's always good, they've put SO, just put that it's the year 2018, because they've then said it changes on how they maintain it using this transition. Okay, so of the length of the roads graded in 2018. So there, when they say that, of the length of roads graded in 2018, so they are just talking about of those 700 to begin with. How many kilometres are expected to be resurfaced? So what you want to look in the transition. So you essentially you want to go from graded, how many we want to see graded to resurface. So this year graded, next year resurfaced, we can see 0.1. So that means 10% of the graded will go to resurface. So that's me explaining this here. 10% of the graded. So we want to set of the one, so they said of the 2018 graded, which is 700. So we're going to say 10% of 700. So that's how many kilometres. So it says how many kilometres? It'd be 70 kilometres. Okay, the next one says, show the length of highway to be graded in 2019. Now remember SO was 2018, so 2019 is S1. Show that the length to be graded is 460. So if we were trying to find S1, what we would do the transition times the one before. So you can see this is here, I've written it out, there's the transition, and we times it by the one before, which they gave it to us. And what they're saying is when you multiply that out, you will get 460 sitting in the grading. And that's fine. And you could do that on the calculator. But they want you to show how that happened. So we've got to remember back to how we manually multiply, and we would do run and dive like that. So really how this number, and it would calculate this number. So remember, we're using row 1, column 1. So it would be, you do 0.2 times the 700, then it'd be 0.1 times the 400, then 0 times the 200, and then 0.2. So there's a way how they catch you out with having to know what is actually happening in the calculator. Okay, the state matrix describing the highway maintenance schedule after 2018 is given by, and this is just our normal pattern of transition. So how we get the next one is we can times it by the one before. So complete the matrix S1. So for 2019. So remember, SO was 2018. So I've just typed it in our calculator. This is the transition from the page before times that SO, and this is obviously giving us S1. And you have to just fill it in, and it looks good because I've got what they said on the top, and then I'm just going to fill in those two, and there we go. So in 2020, so let's just be careful. In 2020, that would be S2. 1,536 kilometres were expected to require no maintenance. So of these kilometres, so they're talking about these kilometres here, what percentage is expected to have no maintenance, expected to have had no maintenance in 2019? So when you're asked to get a percentage, we always say the amount over the total times 100. Okay? Now, when they say of these kilometres, that's generally wording for the total. So we know of these 1536, okay, they were saying how many of them had come from the no maintenance in 2019. So what we're essentially looking at is we're looking at the no maintenance in 2019, and we want to go to no maintenance in 2020. So we look, if you're going from N to N, it's a 0.5. So we're pretty much saying 50% of the one no maintenance in 2019 go to no maintenance thing. Now we can look up, we had 1490 of them. So if you do 1490 times 0.5, we'll end up with 745. Okay, so 745. So of the no maintenance in 2019, 745 of them went back to were still not maintenance. And now we've got that, and we're going to times 100, and we'll get a percentage. And we'll just be careful, it says to 1 decimal place, so that would end up being 48.5%. So this is the answer. Okay, and now it's asking, in the long term, what percentage of the highway each year is expected to have no maintenance? So here I've just put the transition to a high power. I times it by our SO, and we get the answer. So we're looking down here, they want the no maintenance, so I'm going to look that, and it said round to 1 decimal place. So 1 decimal place would be 1532.1. Oh, actually, sorry, I've been called out here. It actually says what percentage. So remember, I should have taken my own advice, is I should be going, percentage is the amount over total times 100. So it says, in the long term, what percentage of the highway each year is expected to have no maintenance? So the down here in the long term, the amount that's going to have no maintenance is 1532. Now, out of the total, now if you will remember way back in the start of the question, we had a total of 2,700. But if you added all these up, you'd get the same amount. And then we're going to times it by 100. So we want that to one decimal place. So we end up with 56.7%. So there's the answer. Okay, in 2009, the school entered a rocket Stedford competition. When rehearsals commenced in February, students were asked whether they thought the school should make the state finals, and they responded yes, no, undecided. How many students are in this school? So all the kids were asked a question, so you have to, and they gave an answer. So if you add all those up, you're going to get the total amount in the school. So there was 500 students. Okay. Each week, the students are expected to change their response, and they change using this transition. The following diagram can be used to display the information represented. Complete the diagram by writing in the missing percentage. So the missing percentage is going from no to undecided. So no this week to undecided is next week is 0.25. So we don't want to put the proportion, we want to put the percentage because that's what they've put there, okay? So the next question, of these students who responded yes 1 week, so of the ones who responded yes, what percentage are expected to respond undecided the next week? So you're at yes and you want to go to undecided. There it is. So they want it as a percentage, not a proportion. So I changed that 0.05 to 5%. And in total, how many students are not expected to change their response at the end of the first week? So when you say not expected to change, that would be all these loop ones. So all those people are going back to their same thing. So what you're essentially saying is you're saying that 85% of yes remain the same because they're going back. And then we're going to say 10% of undecided go back to undecided, and 40% of no go back. Now we've got the totals up here at the beginning because they just said at the end of the first week. So we're going to say 0.85 times how many we had in yes, which was 160, looking up here. And then we're going to say 0.10 of the ones that were undecided, which was 220. And then we're going to say 40% of the no's, which was 120. So you get all those. So we've got all those answers, and then we would add all of them up. So 136 plus 22 plus 48, and we get a total. So we get 206. So how many, just careful, that's what they wanted. How many will not change their response? So 206 students. Okay, here they're just asking us to evaluate S1, which was pretty easy. So we only have to top in the transition and times it by SO, and here we've got S1. So evaluate, so you just have to type it in and show where S1 is the matrix. So you just, for the first week, and you just have to show that, that's S1. Okay, how many of these students are expected to respond yes at the end of the third week? So third week is I'm going to have to do the transition to the power of 3 times the initial beginning. So I can do that where I use that, and we get this would be S3. Now they just want how many would respond to yes. So if we remember back, it was yes, no, undecided. So they just want how many will say yes, so we just have to write 3, 6, 1. Okay, a new colony of endangered marsupials is established on a remote island. For 1 week, the marsupials can feed at 3 of the feeding stations, A, B or C. On Monday, 50% of the marsupials were observed at feeding station A and 50% were observed at feeding station B. So they've just given me, they've like really given me an initial scenario, and I'm just like, I'm writing it as 50, so that means a percentage. I'm just going to write these, contain the percentages. And there's, because there was no at C, so 0 at C. The marsupials are expected to change using this transition. And then it's going to say they create, you get the next one using the normal rule that we're used to. Now, remember, this was on Monday. So SO was Monday, which is why I wrote Monday. Now, from Tuesday to Wednesday, the percentage of marsupials not expected to change their feeding location is. So, if you look at here, this is the transition times, and that's my SO. So essentially this is giving me S1, and S1 is Tuesday. Okay, now they want to say from Tuesday to Wednesday who are not expected to change their feeding thing. So really you want to, when you think about it, you're going to go, if you don't change your feeding, you're going from A to A. Okay, and you're going from, you either go from B to B, back to B, and C back to C. Okay, so if I look up on my transition matrix, A to A is 40% or 0.4, B to B is 0.5, and C to C is 0.6. So we want from the Tuesday people, how many are not expected to change. So I'm going to use these numbers because these are the percentage, because really what we're saying is 0.4. So we're really saying 0.4 of the ones at A, which was 25, and then we're going to say 0.5 of the ones, the ones at B, which was 35, and then we're saying 0.6 of the ones at C, and they're not going to change. So you work out all those numbers. So I've worked out that amount, and then I add them all up and I get 51.1. So remember, I made this was all talking about percentages. So there's D, 51.5%.